Hi, I'm Heather Collins. Hello from Cambridge International, and my goal today is to just show you a variety of woven metal conveyor belts that we manufacture. I'll show you the different styles that we make, the variations, and hopefully speak to some features and thus benefits of our belting. It's going to be a rather casual, informal discussion, so I will go around the table and show you the different types of belts that we offer. The first belt that I'm going to show you is called a balance weave belt. And this is woven by what we call spiral mesh with rods that connect. And you'll actually see that it's got a fair amount of openings, woven wire, and rods that connect it. On this belt, it's not completely finished, so I'll actually be able to pull it apart and put it back together so that you can actually see the configuration. And I'm going to do that now. Can you get on the table? Okay. So you should be seeing the belt on the table at this point. And what I'm going to do is I'm actually going to pull a piece of this belt out so you can see it. This is a connecting rod. It's actually a crimp rod. Where you see these waves or indentations is called a crimp. And that's how we connect the belt together. I'm going to pull two pieces out so that I can actually show you a spiral. This is a spiral. So in our manufacturing process, we produce the spirals and the rods, and then it's actually hand assembled together utilizing the rod and spiral configuration. Okay, there we go. So I'm actually going to connect it together now with the rod. I'm going to piece these two spirals together, nest them together so that they have an intersection point. I'm going to make sure I'm at the intersection point. And I'm going to slide that rod through. It's a very simple process, very easy to do, and you see that I have a seamless belt. That's how a belt is put together when it's a balance weave configuration. Now, in another video, you're actually going to see the differences between this belt and the next belt I'm going to show you. I'm going to talk you through the features of the next belt, and you'll be able to see these documented in a brochure that has been sent to you. The next belt is a balanced flat seat design. It's the evolution from the balanced weave design. What we've done in this belt is we've actually elongated the spirals so you can see that they're long and not round and circular. And we varied the crimp rods so that they nest together better and they do not distort or stretch in an uneven fashion. This was actually a revolutionary design years ago that was designed by our company and has revolutionized the performance of friction-driven metal mesh conveyor belts. And you'll see that in the brochure. Once again, this is a balanced flat seat design. One other thing you'll see in another video is the basic conveyor configuration and drive mechanisms. I've documented that on the board. You will see that. These style belts, for reference, can be driven by friction or positively driven. When they're positively driven, a balanced flat seat belt driven by a sprocket is called our precision system. What we have is a sprocket that actually engages into the belt, and that drive sprocket is the item that provides the thrust or the push to create movement for the belt. So this is our precision system. It was a system designed in answer to some other balance weave belts that were loosely positively driven. As you can see from this sprocket, it has parallelogram shaped teeth that nest perfectly into the spiral so that full engagement does not allow for any shimmy or side to side motion and creates a positive pull through the conveyor. So that's our precision system. Now the next belt I'm going to show you is called our Dura-Hinge belt. This belt was actually designed as a better performing belt to our competitor's belt that's called Flat Flex or also Flex Flow. This belt becomes very brittle as it articulates or moves through a conveyor. The movement and the flexing of the metal spirals, or strands as we call them, creates a brittle belt. These belts can break in days, weeks, or very few months. They're used in different applications from cooling to transfer, to battering, breading, different applications where there is a need for a very open surface area or flow through. The belt we designed hinged better and thus prevented the belt fatigue that we were seeing in the flat flex style belting. And you'll see this also in our brochure described in detail in drawings. So you'll see that hinge in this style belt, the Hinge belt. The next belt that we designed is actually an answer to the breakage and short lifespan of the flat flex of the Hinge belt. This belt is called our Duraflex belt. As you can see, it has a very open surface area. It's much stronger. It has more cross-sectional area, and it's configured in a much better fashion so as to make maintenance and installation much easier. I'm going to go back to this belt for 1 second. This belt requires almost a sewing process to put it together. If you were to have a strand that was as long as this belt, you would actually sew the metal laces through each and every opening to create a seamless belt. This is cumbersome, it's time consuming, it's difficult. The maintenance teams in the factories do not like it. When the line goes down, the last thing they want to do is spend time having to piece this together. And it also creates a fatigue point in the belt because this piece or sewing piece has been fatigued as it's woven through the belt. So in addition to creating a stronger belt with equal surface area, it also has rods that go through it. So whereas I showed you on the mesh belt how the rod simply slid in and it was a 10-second process, this also has a rod and it's a very short, less than 30-second process to seam a belt. You'll see a video also in this package that shows how to seam one of these belts, and you can reference that to see the ease of seaming. This is a belt that the customers are very pleased with and it's performing well. The next belt that we're going to look at is called a flat wire belt. It's configured with a strip of metal that we call a picket, and then a rod that seams the two pickets together to create an endless belt. This belt has a nice open area, as you can see by the shape and size and frequency of openings. It provides a uniform carrying surface, provides airflow for cooling and heating, and it's also a very strong, durable belt that can handle cement bags, metal forging applications, any type of very heavy loads. It also can carry very fast-moving products in assembly lines or processing lines. What we did with this belt was modify the picket design, and you'll see this better in the brochure. There's actually some diagrams to show how we configured the picket such that we decreased the shimmy or the shake between the two pickets and made it a much more uniform belt that nested together better. And in that configuration, what happened was the belt would actually travel smoother, it would wobble less, and it would last longer because there weren't stress points all across the belt. And once again, you'll see that in the brochure. So that's called a flat wire belt. Our design is a pack type. The next belt, and I'm actually going to walk around the table, is called a compound balance belt. This is a balance weave belt where the spirals are actually nested together in a series of multiples so as to create a solid surface. This can be used in any type of situation where there needs to be a solid, uniform heating surface or carrying surface. This can be found in baking. We call them baking bands. You'll find these where the product is actually placed right on the belt as opposed to in pans, or in some types of metal processing with very small pieces and parts. So this is a compound balance belt, something that you may run across in the different markets or industries. Now the next style belt has a bunch of different components. I was actually able to pull together a sample that's a very custom specialized belt. And what I hope to achieve by showing you this belt is to show you the different pieces and to show you how custom some of the belts we manufacture are. This is actually called a chain drive belt, and it's chain drive because you'll actually notice there's chain on the edge of the belt. Now that chain could be a roller type chain, as you see here with the rollers, or it could be a pintle chain. This is a very large pintle chain, so that would bring to mind some very large metal processing applications that require heavy loads and a strong pull. So you'll see this in metal processing. So here again, you could have two different types of chain. You typically will have a woven mesh to support the product, and then you have rods that go through to not only the mesh rods that are very small in this case, but then you'll actually have, I'm going to try to lift this up, rods that go through to connect the mesh to the chain, and those are called chain rods. This belt also has side plates, so as you can imagine, the product would be piled or stacked on the belt, and these side plates prevent the product from moving off the side of the belt. So this is a custom designed belt with mesh, chain rod, side plate, and roller chain. Speaking of chain, we do all different types of chain from pintle to roller, but then different types of roller chain depending on the requirements of the apparatus or the conveyor system and the loads that they'll be facing. So we do those also. One last thing I have here easily to show you is a belt with a flight. In another video I mentioned that I had neglected to do this. I've come back and done it. This is a flight adhered typically by a plug weld to the belt. As you can imagine, the product would be being carried up an incline, and this flight would hold the product in place so that it didn't roll off the belt. So those are some designs of our very custom style belts. From this presentation, you've seen balanced weave, you've seen Durahinge, you've seen Duraflex, you've seen flat wire. You've seen a good assortment of the different style belts that we offer. And I hope this was informative for you. Thank you.